Welcome to the solution to the web homework 3 for this course. I thought I would just start with a quick refresher of our kinematics equations in one dimension. These first three equations here are when we have motion with constant acceleration, and here your displacement or your change in x is equal to the initial velocity in the x direction times the time interval plus 1/2 times the acceleration times the time interval squared. And we have a similar two other equations with similar variables. And this fourth equation is when we have motion with constant velocity. If you notice, if we go back up to the first one, if we just set the acceleration to equal 0, we get this last equation. Okay, then down here I have just some notation for you who may have forgotten. The displacement or the change in x is your final position minus your initial position. Same with the time interval. And here are some definitions of the other variables. Okay, why don't we get to the first part of this homework. So here we have a projectile is being launched at ground level with an initial speed of 50 meters per second at an angle of 30 degrees above the horizontal. It strikes a target above the ground 3 seconds later. We're asked for the x and y distances from where the projectile was launched. The target. So here I've drawn a picture of this scenario. So this point right here, this YF and XF, that's the final position where our target is. And that happens at our final time, which is given to be 3 seconds. It starts at ground level over here, and I've drawn the initial velocity here, I should label that, along with its y and x components. So this is our figure. Notice the x and y axes here. They're labeled so we can refer to those directions. Okay, let me just label this. This is our initial velocity as a vector. Alright, let's write down everything we're given. So first of all, at t equals 0, we know that our initial position, x0, is 0, and that's the same as our initial y position. Also, we know that our initial velocity is 50 meters per second, 30 degrees above the horizontal. Now, we're going to have to do something with that velocity because expressing a vector in that way is not the most useful. Okay, so at our final time, that's 3 seconds, we know we're at position XF, which we do not know the value of. Same with, not another X, but YF, which is equal to something we do not know. Okay, so what's the first step in this? Well, let's work with our velocity. Our initial velocity, we're going to write it in component form. So in component form, we can write the velocity as Vx0 in the x direction plus Vy0 in the y direction. So it's just up to us to determine Vx0 and Vy0. Note that there's an angle here, which is 30 degrees. Okay, well, Vx0 is just the magnitude of V0, or the speed, which is 50 meters per second, times cosine of 30 degrees. And plugging that into your calculator, you should find that to be 43.3 meters per second. Similarly, we can find Vy0. It's 50 meters per second times sine of 30 degrees. And that's equal to 25 meters per second. Okay, so those are our initial velocities in the x and y direction. Now we can go ahead and just figure out what our final x position is, because in the x direction we have motion with constant velocity. Remember that the acceleration here is only the acceleration due to gravity, and the acceleration due to gravity is straight down. So we don't have to worry about acceleration in the x direction. Okay, so we can use our equation, motion with constant velocity. Our final x position is equal to our initial plus our initial velocity in the x direction times our time interval, which in our case is just our final time. So this is 0 plus 43.3 meters per second times 3 seconds. And that gives us a final x position of 130 meters. Okay, so that's the distance traveled in the x direction. So we've found half of the problem. Now what about the y direction? So in the y direction we have motion with constant acceleration. So our change in y is equal to our initial y velocity times our time interval, which is tf, plus 1/2 ay times delta t squared. Okay, now we just plug in our numbers. Our initial velocity is 25 meters per second. Our initial time our time interval is 3 seconds plus 1/2 times negative 9.81 meters per second squared. That's the acceleration due to gravity times 3 squared. Okay, that gives us a delta y of 30.9 meters. You can verify that. That would be great. So this implies that our final y position is 30.9, since delta y is equal to y final minus y initial, and y initial is 0. There we go. So that's the x and y position of this object which we hit with our projectile.